Hi everyone, in this video we're gonna talk about how to use the ratio test to check the convergence of this infinite series. Alright, so for the ratio test, we start with finding the limit of this ratio, absolute value of an plus 1 divided by an. And if the ratio is less than 1, then the infinite series converges absolutely. And if the ratio rho is greater than 1, then the infinite series diverges. And if rho is equal to 1, then the test is inconclusive. Okay, so we start with finding this limit. Limit n approach infinity, absolute value of an plus 1 times 1 over an. And then we see that with the absolute value, what we have here is negative 1 raised to n, but when we take the absolute value, it's gonna be 1 anyway. Even this is not always positive, but when we do the absolute value, it's gonna be positive. Okay, so we have an plus 1. So every when you see n, by the way, this is let's say this is our an. So for an plus 1, everywhere you see n, you change to be n plus 1. So we have this one times n plus 1 factorial square divided by 2 times n plus 1 factorial. Okay, times 1 over an. So an is like this. 1 over an is the reciprocal of this one. Okay, so we have 2n factorial divided by negative 1 raised to n times n factorial square. Alright, so we simplify. What is this one? This is negative 1 raised to n times negative 1 raised to 1, which negative 1 raised to n that's cancel out. And then we see that n plus 1 factorial is n factorial times n plus 1. Okay, because let me write down here. Actually, I have done it in the previous example. N plus 1 factorial is mean 1 times 2 times 3 times up to n times n plus 1, which we see that this is n factorial. That's why n plus 1 factorial is equal to n factorial times n plus 1. Okay, and so what we have here is the limit n approach infinity, absolute value of, that's what remain, negative 1 times, okay, I will, so n plus 1 factorial is n factorial times n plus 1 square. Okay, and then at the denominator we have n factorial square. Okay, now let's work on this one. What is this one? Okay, let me do it here. So this is 2n plus 2 factorial. Okay, because we distribute inside, so 2n plus 2 factorial. And what's 2n plus 2 factorial mean? 1 times 2 times up to 2n times 2n plus 1 times 2n plus 2, right? Okay, from here to here add by 1 unit, from here to here add by 1. Okay, so we have like this, which we see that from here to here, this is 2n factorial. Okay, that's why this is equal to 2n factorial times 2n plus 1 times 2n plus 2. Okay, that's what we have for this one. 2n factorial times 2n plus 1 times 2n plus 2, which again we see that 2n factorial and 2n factorial is cancelled out. Okay, so what we have at the bottom is like this. Okay, so here nothing left, so we just put 1. And then what is this one? What does this mean? It means n factorial square times n plus 1 square. Okay, because this square is for this and for this. Okay, and then we see that this is the same, so we cancel out. Okay, so we have n plus 1 square divided by 2n plus 1 times 2n plus 2. Okay, by the way, with the absolute value here, absolute value of negative 1 is 1. Okay, and the rest here, they are all positive anyway. Okay, that's why we have this limit. What's the limit? Numerator, we have n squared plus 2n plus 1. Divided by the denominator, we distribute them all. Okay, so we have 4n squared plus 6n plus 2. Okay, like this. Okay, and then just in case you don't see, this is 4n squared, this time this plus 4n, this time this plus 2n, this time this plus 2. That's how we get this one. Okay, alright, so for the limit, then the shortcut is like this. Compare numerator and denominator. Since the degree is the same, we just take the leading coefficient divide by the leading coefficient. That's why the limit is equal to 1 over 4, and which is less than 1. So by the ratio test, if the ratio is less than 1, then this infinite series converge absolutely. That's why the answer for this problem, this one converge absolutely.